Welcome to The Explainer. Today, we're going to demystify one of the most powerful ideas in all of technology, the neural network. But don't worry, forget all the complex math for a minute. We're going to build one from the ground up, just by hiring a team of digital interns and teaching them how to think.
Okay, so let's just dive right in. And for a second, let's forget about computers entirely. I want you to imagine you've just hired a whole team of interns. They're super eager, but they're completely inexperienced. You can't possibly write a rule book that covers every single task they might face. So instead, you have to teach them to think, how to spot patterns, and most importantly, how to learn from their mistakes. And that right there, that's the core idea behind a neural network.
All right, so here's job number one for our brand new team. Picture this. We're in a mailroom, and there is a mountain of letters. Their one job is to sort every single piece into just two bins, urgent and not urgent. Now, it sounds simple enough, right? But the real trick is, how are they going to decide?
Now, here's the most important part. We are not giving them a list of rules. We're not going to say, hey, red envelopes are always urgent. No way. The whole point is to let them discover the patterns for themselves. Is it the type of stamp, the handwriting, maybe the return address? They have to figure it all out. This whole process is called pattern recognition, and it is the perfect first job for our new team.
So each of our little digital interns represents what's called a neuron. You have to understand, a single neuron isn't very smart. It can only do one tiny little thing, like make a very simple yes or no kind of judgment. But when you connect a whole team of them together and they all start working together, well, that's when the magic really starts to happen.
Okay, so let's get our team of neurons organized into a really efficient system. The best way to think about it is like an assembly line. Information comes in one end, it gets processed at each station along the way, and then a final decision pops out the other end. In the world of AI, this kind of one-way street for information has a name. It's called a feed-forward network.
So at the very beginning of our assembly line, we have what's called the input layer. And you can think of this as our mail clerk. Now, this person's job is not to make decisions, not to think at all. They just observe. They pick up a letter, and they just call out the basic facts. The address is handwritten. It has a red stamp. This one feels kind of heavy. They're just collecting the raw data. That's it. That raw information then gets passed on to our team of interns, the hidden layers. Why are they called hidden? Well, it's because we don't really interact with them directly. We only see their final, combined result at the very end. Each intern in this layer takes those features from the mail clerk and starts to form a tiny opinion, weighing some facts as, maybe a little more important than others.
So let's just watch this thing in action. The clerk at the input layer, they just note the features. Then the first intern in the hidden layer takes those features and passes along a little confidence score. The next intern down the line adds their own judgment and tweaks that score. And finally, the last intern in line, we call that the output layer, makes the final call. And what you'll notice is that the information only ever moves forward, from start to finish.
Okay, so the team is all set up, our assembly line is running, the very first letter comes sliding down the line. This is it, the moment of truth. How is our brand new, completely untrained team going to do on their very first attempt? Now, it's really important to remember this. They have absolutely zero experience. None. So the importance they decide to place on a red stamp versus, say, handwritten address, it's completely random. It's basically a total shot in the dark, a wild guess.
And the final intern confidently shouts out, "Urgent!" But yeah, the letter was actually just a birthday card from somebody's grandma. They got it wrong. And this moment right here, this mistake, this is the single most important event in this entire process, because a mistake is an opportunity.
This is where the real learning kicks in. A manager, who kind of represents the training algorithm, steps in to do a little performance review. This whole feedback process, where the information about the error gets passed backward through the network, has a fancy name. It's called backpropagation. Now, a good manager doesn't just walk up and say, "You were wrong." I mean, that's not helpful, right? Instead, they provide really specific, useful feedback. They say something like, "Okay, you were 80% confident this was urgent when you really should have been 0%. Your guess was way off." And this right here, this is the core of all learning, whether we're talking about humans or machines. It's not about being perfect from the start. It's all about getting specific, actionable feedback that lets you adjust your thinking for the next try. And here is the absolutely crucial part. That feedback travels backward down the assembly line. The manager gives feedback to the final intern.
That intern then turns to the one right before them and basically says, "Hey, your input made my final guess way too confident." And this continues all the way back to the start, with every single intern making a tiny little adjustment to how they weigh information.
Okay, so that whole feedback loop just happened for one single letter. Now, I want you to imagine our team doing this again and again and again. Thousands, maybe even millions of times. A letter comes through, they make a guess, the manager gives feedback, and everybody adjusts just a little bit.
So on their first attempt, their accuracy is basically a coin flip, 50-50. But after just 100 letters, look at that, it's already up to 72%. And after 10,000 letters, they are sorting with 98% accuracy. It's amazing. Through just sheer repetition and these constant tiny little corrections, the team as a whole becomes incredibly smart.
And here's the big takeaway. They are not just memorizing answers, no. They have collectively learned the subtle underlying patterns that actually define urgent mail. It's like they've built an intuition for it, all without us ever giving them a single rule. That is the essence of machine learning.
And while our little mail sorting analogy is pretty simple, right? The incredible thing is that the fundamental process is exactly the same for some of the most complex AI systems in the entire world. Whether it's an AI learning to spot a cancerous tumor in a medical scan, or predict a hurricane's path, or translate between languages in real time, it all comes down to learning patterns through feedback, just on a massive, massive scale.
So we started with a team of clueless interns, and now we've built a team of experts. We have this incredibly powerful tool that can learn and find patterns that maybe even we would miss ourselves. And all this brings us to a pretty big question. Now that we can teach machines how to learn, what are the most important things we should be teaching them next?